This question asks us to balance the combustion of propane, C3H8, with oxygen to produce carbon dioxide and water vapor. Let's write out this reaction. We have C3H8, liquid, reacting with oxygen. Remember, oxygen's O2, not O on its own, to become carbon dioxide, CO2. That will be a gas. And water vapor, H2O. And because it specifies vapor, we also know that it is a gas. Let's break up our page. We have three atoms here. We have carbon, hydrogen, and oxygen. We have 3 carbons, 8 hydrogens, 2 oxygens in the reactants. We have 1 carbon, 2 hydrogens in the products, but we also have 3 oxygens. Now, the way that the oxygens are in this equation is it's in 2 different substances. So instead of my usual way, I'm going to write it through addition. 2 plus 1 equals 3. The reason I'm doing it like this is this indicates that I have 2 oxygens in the carbon dioxide and 1 oxygen in the water vapor. So I have a total of 3, but I also see where each of them is coming from. This is going to allow me to adjust one molecule and still get an accurate count of oxygens. Let me show you how it works. When I do this reaction, I want to leave the oxygen until the end. The reason I want to do that is because this oxygen molecule is nice and simple. Now you might think, doesn't that mean I want to do it first? But it actually means you want to do it last, because you can change the number of oxygens here without unbalancing something else. So instead of starting with the oxygens, I'm going to start with the carbons. I have 3 carbons in the product, or in the reactants. I need 3 carbons in the product, so I'm going to multiply it by 3. Whatever I do below, I have to do above. And whatever I do to the carbon, I also have to do to the oxygen. This is going to look a little bit different though, because this time I'm taking the 2 oxygens and multiplying it by 3. So instead of having 2, I now have 6. I also only have 1 oxygen still in my water molecule. So now I have 7 oxygens total. See why we want to leave the oxygens till the end? Okay, my carbons are balanced out. I want to balance out my hydrogens too. I have 8 hydrogens in my reactants. I have 2 in my products, so I'm going to multiply it by 4. That's going to give us 8 on both sides. Whatever I do down below, I have to do above, and whatever I do to the hydrogen, I also have to do to the oxygen. Same thing with this one. Now I'm going to multiply the single oxygen by 4. And don't get pulled into the trap of thinking that now it's 11, because you're not adding 4 to 7, you're adding 4 to the 6 you have in the carbon dioxide. So I change it to 1 times 4. Now I have 6 plus 4 equals 10. I have 10 oxygens in my products. I only have 2 in my reactants. That means I need to multiply it by 5. Whatever I do down below, I also have to do up above. And that gives me a balanced equation. I have 1 propane reacting with 5 oxygens and 3 carbon dioxides and 4 waters. Now, What if we tweaked this question a little bit? Instead of propane, what if we used ethane? Ethane's a very similar chemical, C2H6. It will be a gas. We're going to react it with oxygen as well. It's going to become, just like the propane did, carbon dioxide plus water vapor. This is the same type of reaction, it's just using a different reactant to get it going. So we have C2H6 plus O2 becoming CO2 and H2O. I'm going to divide up my page, and I'm going to set it up pretty much the exact same way. But you're going to see this is a little bit different. So I'm going to show you a trick to make this a little bit easier. I have carbon, hydrogen, oxygen. I have 2, I have 6, I have 2, I have 1, I have 2, and I have 2 plus 1. Okay, I'm going to go about this the same way. I want to balance out my carbons, so I times my carbon in my products by 2. That's going to change it so that now I have 5 oxygens. I also want to balance out my hydrogen, so I need to multiply by 3. That's going to give me 6. Now I need to put that 3 up as a coefficient as well. This is where things get a bit tricky for me, because now I have 4 plus 3 equals 7 oxygens. That's not necessarily a bad thing, but we want to have whole numbers in our balanced equations, and it's difficult to balance out oxygen because there's 2 on one side and there's 7 on the other. But 7's an odd number. 2 doesn't go into it easily. So what we can do here is we can temporarily use a fraction. We don't want to use fractions in Science 10 a lot. There are sometimes it's allowable in higher level chemistry, but we don't want to use them. We want to use whole numbers, but we can use it as a temporary way to get past this impasse. We see that there's 2 oxygens in the oxygen molecule. We want to get that down to 1 so it can go into an odd number a nice number of times. So what we're going to do is we're going to set up a fraction over 2, because 2 divided by 2 is 1, right? Now, if I just have 1 oxygen there, can I get it up to 7? Yes, I can. So if I make it 7 halves, it will give me a 7 over here. Now, like I said, we don't like this in chemistry. We like it to have whole numbers. So how do I get rid of a 2 in a fraction? Well, I'm going to multiply everything by 2. If I multiply the entire equation by 2, everything will still stay balanced. Because we have 2 carbons on each side, well, now we'll have 4 carbons on each side. We have 6 hydrogens, now we'll have 12. We have 7 oxygens, now we'll have 14. So what that means we have to do is we need to change all of these coefficients. The carbon, or the ethane, got multiplied by 2, so it gets a 2 in front of it. The oxygen's actually nice and easy, because we multiply it by 2, it just cancels out the 2 on the bottom, so we can erase our fraction. The carbon dioxide was 2, so it becomes 4. and the water molecule was 3. So it becomes 6. And now we have a balanced equation. 2 ethanes reacting with 7 oxygens becomes 4 carbon dioxides and 6 waters. So we've just used a fraction in this equation temporarily as a way to get us over the fact that there was an odd number and odds can't go into evens. After that, we cancel the fraction out and we're left with a perfectly balanced equation.